Are you ready for the next internet revolution? Forget humans browsing websites. We're talking about autonomous AI agents collaborating across systems, making decisions, and taking action. This isn't just hype. It's the inevitable future. But there's a problem. These agents are currently isolated, like islands in a vast ocean. They can't communicate, they can't coordinate, and they're missing a crucial piece of the puzzle. What if I told you there's a new stack emerging to solve this? A stack that will unleash the true potential of AI agents? It's built on open protocols and shared infrastructure, and it's about to change everything. Think about it. Most companies won't just deploy one AI agent. They'll deploy dozens. These agents will be writing code, handling customer support, analyzing data, and managing infrastructure. But today's tools aren't ready for that future. We're not just facing the island of agents problem. We're facing a broader ecosystem fragmentation. Agents don't talk to each other. Tool usage is brittle and bespoke. Frameworks lack consistency. We're building as if agents live in notebooks, and there's no backbone for collaboration. This leads to silos, duplication, and fragility. We need a solution that goes beyond isolated bots. We need a shared stack, a new foundation based on open protocols, event-driven architecture, and real-time processing. The key lies in four powerful components: Google's A2A agent, Anthropic's Model Context Protocol, Apache Kafka, and Apache Flink. Let's break it down, because it's about to get interesting. Let's start with Google's A2A agent, or A2A. Imagine the early days of the web before HTTP. Websites couldn't easily communicate, and everything was a custom integration nightmare. A2A is like HTTP for AI agents. It's a universal protocol that allows agents to discover, communicate, and collaborate with each other, regardless of who built them or where they run. It's not just another agent framework. It's a shared language for agents. They can announce their capabilities via an agent card, send and receive tasks through structured interactions, stream updates with server-sent events, exchange rich content, and stay secure by default. What makes A2A so promising is that it builds on decades of internet protocol history, leveraging familiar, battle-tested web standards. Adoption becomes easier, and integration becomes faster. But A2A is only one half of the equation. Now, let's introduce the other player. Enter Anthropic's Model Context Protocol, or MCP. This tackles the other half of the problem: how agents use tools and access context. MCP standardizes how agents invoke APIs, call functions, and integrate with external systems. It's essentially how they think and act in the world. If A2A is about giving agents access to each other, MCP is about giving them access to tools. Together, these two protocols offer a blueprint for a connected agent ecosystem. MCP powers individual agent intelligence, while A2A enables collective intelligence. But just like HTTP and SMTP needed an ecosystem to thrive, A2A and MCP need infrastructure to realize their full potential. Even with standardization, a fundamental question remains: how do these agent communications scale effectively across a complex, dynamic enterprise environment? Relying solely on direct connections creates challenges around scalability, resilience, and observability. That's where Kafka and Flink come in. Imagine a company where every employee can only communicate by sending direct, one-on-one messages. Need to share an update? You have to message each person individually. Want to coordinate a project across 5 teams? You're stuck manually relaying information between every group. Now imagine trying to scale that to hundreds of employees. Chaos. That's exactly what happens in agent ecosystems built on direct connections. Every agent must know who to talk to, how to reach them, and when they're available. As the number of agents grows, the number of required connections grows exponentially. The system becomes brittle, hard to manage, and nearly impossible to scale. A2A and MCP give agents the language and structure to communicate and act, but language alone isn't enough. To coordinate dozens or hundreds of agents across an enterprise, you also need infrastructure for how those messages move and how agents react to them. Think of Kafka and Flink as the central nervous system for your AI agents. Let's introduce the powerhouses, Apache Kafka and Apache Flink. Kafka is a distributed event streaming platform, originally developed at LinkedIn. It acts as a durable, high-throughput message bus, allowing systems to publish and subscribe to streams of events in real time. It's used everywhere, from financial systems to fraud detection to telemetry pipelines, because it decouples producers from consumers and ensures data is durable, replayable, and scalable. Flink, also an Apache project, is a real-time stream processing engine. It was designed from the ground up for stateful, high-throughput, low-latency event processing. Where Kafka handles the movement of data, Flink handles the transformation, enrichment, monitoring, and orchestration of that data as it flows through a system. Together, they form a powerful duo. Kafka is the bloodstream, and Flink is the reflex system. They are the infrastructure that allows your agents to react in real time, to learn from each other, and to make intelligent decisions. Just as A2A is emerging as the HTTP of the agent world, Kafka and Flink form the event-driven foundation that can support scalable agent communication and computation. They solve problems that direct, point-to-point communication can't. With Kafka, agents don't need to know who will consume their output. They publish events like task completed or insight generated to a topic, and any interested agent or system can subscribe. Kafka maintains a durable, time-ordered log of every event, making agent behavior fully traceable, auditable, and replayable. Flink enables agents to react in real time to streams of events, filtering, enriching, joining, or triggering actions based on dynamic conditions. Flink jobs can scale independently, recover from failure, and maintain state across long-running workflows. This is essential for agents that perform complex, multi-step tasks. Instead of waiting for a synchronous response, agents can coordinate through streams of events, publishing updates, subscribing to workflows, and progressing state collaboratively. Let's simplify it even further. In short, A2A defines how agents speak. MCP defines how they act on external tools. Kafka defines how their messages flow. And Flink defines how those flows are processed, transformed, and turned into decisions. Protocols like A2A and MCP are essential for standardizing agent behavior and communication. But without an event-driven substrate like Kafka and a stream-native runtime like Flink, these agents remain stuck in isolated interactions, unable to coordinate flexibly, scale gracefully, or reason over time. To fully realize the vision of enterprise-grade, interoperable AI agents, we need 4 layers: protocols, A2A and MCP, to define the what; frameworks, LangGraph, CrewAI, ADK, to define the how; messaging infrastructure, Apache Kafka, to support the flow; and real-time computation, Apache Flink, to support the thinking. This is the new internet stack for AI agents, a foundation for building systems that are not only intelligent, but also collaborative, observable, and production-ready. This is how we move from isolated experiments to true collaborative AI. We're at a pivotal moment in the evolution of software. Just as the original internet stack unlocked a new era of global connectivity, a new stack is emerging for AI agents. But instead of humans navigating pages or sending emails, this stack is built for autonomous systems working together to reason, decide, and act. A2A and MCP provide the protocols for agent communication and tool use. Kafka and Flink provide the infrastructure for real-time coordination, observability, and resilience. Together, they make it possible to move from disconnected agent demos to scalable, intelligent production-grade ecosystems. This isn't just about solving engineering challenges. It's about enabling a new kind of software where agents collaborate across boundaries, providing insight and action flow in real time, allowing intelligence to become a distributed system. This is a game changer. This is the future of work. This is the power of collective intelligence. But this vision won't realize itself. We need to build it openly, interoperably, and with the lessons of the last internet revolution in mind. So, the next time you're building an agent, don't ask just what it can do. Ask how it fits into the larger system. Can it communicate? Can it coordinate? Can it evolve? Because the future isn't just agent-powered, it's agent-connected. Are you ready to build that future? Let me know your thoughts in the comments below. What are you building with AI agents? And how are you thinking about collaboration? Don't forget to like and subscribe for more insights into the world of AI. Thanks for watching.